Hi and good evening, it's Gene from the maverickstar Observatory. Guys, in this video we've got coming up the Trimack Data, the Magnetosphere Data. We're going to have a look at those a bit later on. And we've also got on Google Maps the latest position of where the magnetic North Pole is right now. So let's get into it. So as you can see, we've put the pin on the 19th of the 1st, 2020. It's the first of the 2020 readings, and it's moved approximately 3 miles, so still progressing towards Siberia. A bit later on I'm going to pull up the line tool on here so we can have a look at which is the heading, and we'll zoom out and we'll see roughly if it carries on that heading where it will hit around about Siberia. But if you look at the bottom of the screen, you'll see the longitude and latitude. First of all, the northerlies, we've got 83 degrees by 58, just been covered up by my computer having a nervous breakdown. Okay, so we have, if I put the cursor on the pin, so it's roughly 83, 55, 13, 25 north by 127 degrees, 09, 58, 53 east. So let's zoom out and we'll see where that is heading. So as we zoom out, you'll see the pins start to close up a lot closer to each other. And we can see now the 40-degree mark coming in. If you're new to the channel, the reason why we've put the 40-degree mark is when the magnetic North Pole has migrated a total of 40 degrees when we was doing experiments with compasses and magnets. When it got to 40 degrees, we could see that it was leaving those strong field lines that keeps it held in place for longer periods of time. When it goes into the weak field lines, which is past 40 degrees, what happens is the field is weaker and the poles seem to flip from 40 to 40, and then if that happened tomorrow, it could probably end up somewhere else in the world, the North Pole, but it would take another 100 years, as it has, to reach and settle down to its resting position. That is, of course, if it's not an excursion and it is a completed reversal. So let's go back a little bit and just zoom out a little bit more, and we should see the continent and Siberia coming into the screen. So if I just put up the measuring tool and measure where roughly the North Pole is right now, and if we can roughly draw where it's going to be, we can see it's around 547 miles off the coast of Siberia. As you can see, the heading is 213 degrees, or it probably would look a little bit better like that. So 216 degrees is the heading of the magnetic North Pole right now, heading towards, as we said, Siberia. So I'll just zoom out a little bit more so you can see where it's migrated over the last 100 years. And one thing I'll say here is that as it has been migrating, there's been 3 different shifts in speed. So the further it's migrated from Canada, it accelerated once, and then a little bit later it accelerated again. But the way it did it was linear. So it went from, if you want, it started at say 1 to 2, then went to 2 to 4, and then at the end it went from 4 to 8. So you can see, if you can just picture in your mind the curve of how fast it's been going and covering more distance over less time. So the pole is still migrating. Let's have a look now at something else related to the poles. In the core of our Earth, we've got the magneto, and it doesn't just generate a dipole at either end of our northern and southern hemispheres. It also protects us with the completed magnetosphere strength. And one of the things we look at, not just the position of the magnetic North Pole, is also the magnetosphere strength. And if you've been following for a few months now, you'll see that we're also measuring the magnetic intensities in various parts of the world, and we're going to be putting some more magnetometers out this month. Hopefully we'll have them finished. I'm working at the moment on the muon detectors, and magnetometers at the moment. And when we've got all those together, built around about the 1st or 2nd of February, hopefully we'll be shipping them out to their destinations, where we can keep a track on not just the intensities like we do already in Hong Kong, Australia and America and here in the UK, but we'll also be able to put 2 more muon detectors out in Brazil and South Australia, and that gives us an idea of how much protection we get in the strong fields in Australia and how much we get in the weak fields like in Brazil. Because why we want to measure these things, and this is really going to be a big thing that we're going to spot straight away the difference, if there is any, because when the magnetosphere collapses during the reversal or past the 40-degree point where things start to accelerate, the magnetosphere will begin to rapidly deteriorate from that point on. And when it does that, we should have more muons in that region. So if the whole of the Earth's magnetosphere weakens it at the same time, we'll have more cosmic radiation inbound, we'll have more collisions in the upper atmosphere, and our muon detectors that detect muons, which are byproducts of these cosmic ray collisions, will be able to detect an increase at that point. But why we want to put it in Brazil is because we already have the South Atlantic anomaly, which is a low intensity of magnetism right now. So we can get an idea of how much is actually inbound in a low intensity region as opposed to a high intensity region. So let's have a look at the Trimack data over the last month and the Magnetosphere data, and we'll wrap it up. So guys, we're on the Trimack Data page of the website poleshiftnews.com. If you want to go over there, you'll see all of the data that we collect here at the maverickstar Observatory. But this is the chart I was talking about, the North Pole migration, these miles. And as you can see, it started to migrate in the 1900s, went around 90 years, and then accelerated to around the year 2000, and then accelerated again up to the present date, and it's still continuing on that line. But if you just look at how fast it accelerated over 90 years, it was 500 miles, and then over a period of from 20 years, it had accelerated 1,000 miles. So you can see it's covering more distance. And then from 2010 to 2018, so only 8 years, you can see an even more of an acceleration of around probably 600 miles. So from the 1990s to the present day, it's moved 1,000 miles as opposed to the 1900s to 1990. So 90 years, moved 500 years. From 1990 to the present day, it has moved over 1,000 years. That just gives you an idea of how things are starting to pick up as we approach that 40-degree mark. So let's have a look at the data from the Trimack this month. As you can see, if we just quickly scatter down, it's always around 13 degrees. What that means, if you have a look here, you can see the key to reading these charts. What that means simply is we calibrated the Trimack, which is 3 magnetometers, at 10 degrees, and over the time period, if we scan right the way down, you'll see that it moved from 10 degrees around 2 years ago to where it currently is right now. And these were the 3 original readings off each Trimack, off each mag that we've got in the Trimack pack. So, and that's all of them together at the top in the blue. Actually, it's not, it's actually all of them together in the bottom, 1, 2 and 3. So it shows you that line that's moving just gradually on the green graph. What that's an indication of, you do get some fluctuations, even on a daily basis you get fluctuations, but you can see that they was all calibrated virtually perfect when we started. And if we just go back to the present day, you can see that gradually, I'll sort of do it a bit slower than that so you can actually see it gradually has moved around 3 degrees, and that in 2 years is equivalent to about 140 miles or thereabouts, something like that. So a little bit more than what NOAA are telling people it's migrating, because they say on average it migrates around about 40 miles a year. It's a little bit more than that, and you can see that over the month that we've got here, it has moved up a little bit and down a little bit, but it seems to have slowed down. And I noticed which I'm going to show you next on the magnetosphere sensor, something similar has been taking place, which could be related to the fact that when we look at the last month's chart, there was more bumps in the chart. This month, not so many, but this month also, it only migrated 3 miles as opposed to last month, which was just, I think, about 4.2 miles, something like that. So let's go and have a look at the magnetosphere chart. So again, on poleshiftnews.com, if you go down to, or go across to Magnetosphere Data, what you'll come across is all the data related to the magnetosphere that we collect here at the observatory. The key is there at the top of the page to understanding where we calibrated it at, and if we just get a couple of the charts in there, we can see roughly what's been going on over the last 2 months. I did notice that around about a week and a half ago, looking at the chart of this month's data, there was a slight drop of nearly 1 microtesla, which is quite a lot, guys, when you think about it. You know, our Earth's surface, or our Earth's magnetosphere strength, is only around about 58 microteslas. So to have a 1% in a month drop like that, it's quite a lot. Still though, buffeting around 190 microteslas. Now I know what you're thinking. If the Earth's only got 58 microteslas, how come we're on the scale of 199? Well, the reason why I set it at 199 is because if it drops a lot more or goes up a lot more, we've got more of a range. If I bring the range down, what happens is it goes over to 360 when it goes beneath 0 for some reason. I don't know why it does that, but that's why we calibrated it at what we did, so that we had plenty of range of movement either way. So yeah, so we had a little bit of a drop of about a microtesla, then it came back up just recently to 199 microteslas as measured on the chart. So guys, just before we end out the video, I wanted to introduce you to a gravity map. You may have seen one before, but may not have. And one of the things of interest about this map is that you'd think the Earth's surface would be the same. Apparently, around the equatorial region it's slightly less, and you know, it does vary in different places. Like if you was on the top of Mount Everest, the gravity would be less. As you go up in altitude, the gravity becomes weaker. At the very lowest sea level surface, it's at its strongest generally, but as we can see, there are some blue patches where, you know, the actual gravity is less. So I thought, you know, if I can get one of these widgets to fit on the website, I thought that would be a great map to add to the ones that we've got up on there already. So guys, before I finish the video, I'm going to say big thanks to those that support us on here. You know, we build equipment, we don't just talk about these anomalies, and we track it regularly. You know, we've got some great people that are participating in this all around the world. You guys know who you are. You know, we've got some more people joining the team that are going to be having magnetometers, muon detectors, and we'll be collecting more data, and as a result of that, we'll be in a better position to guess, or you know, make some predictions as to what's going on with not just the pole migration and the magnetosphere weakening, but you know, with now the increase in cosmic rays, because we know as a result of low solar activity, which we've experienced now for the last 3 solar cycles that last 11 years each, what we know is that when the solar cycles drop, we get more cosmic radiation inbound as a result of the heliosphere shrinking, and if we're having an Earth's magnetic reversal, the magnetosphere will reduce in strength, and again more cosmic radiation in. So from an observatory point of view, we're on the money, we're covering what we need to, and you know, we just need to continue spreading out across the world. And you know, you never know, guys, we might be bigger than NASA one day, you never know. I mean, one of the very first computers was built in a shed after all. So yeah, big thanks to you guys on Patreon and PayPal that support us. Big thanks to our superstars, Doug and a few others. You know, all as I can say, guys, is there's a link down there if you want to help support what we do. And you know, there is some expense going out this month with regards to, you know, the increase of our network of sensors and detectors. So you know, the links are there. Okay guys, I won't go on. I'll probably catch up with you tomorrow with a CO2 report. We'll have a look at the muon detector. We'll see what the muons are doing at the moment, whether they've increased and decreased. Again, very strange, because you know, it fluctuates from week to week by about 100 muons per meter per square. It's interesting. You know, it'd be better when we start graphing all this, and that's coming online very shortly as well, and that will be added to the website. So guys, big thanks to you guys that support us. If you want to, links are down there. And I'm going to get out of here, guys. I'm going to say one thing. Have a great evening, and as always, bye for now.